name is Sam. I'm the CEO of PlanetScale. We are a very reliable and performant database platform supporting Vitess MySQL, Postgres, and soon sharded Postgres in the form of Niki. These are some of our customers. I'm going to give a very quick presentation about what we do and then live shard a database on our platform. So one of the technologies we're known for is Vitess. Vitess is a sharding framework for MySQL. We are the maintainers of Vitess, and we're the largest relational database on Earth runs in Vitess, and some of the largest out there, with some of these being the users of Vitess and our customers. We can host PlanetScale inside your AWS or GCP accounts. We deploy our data plane in there, but it feels like a fully managed service for you. And we're extremely fast. In fact, we are the fastest Postgres host and MySQL host that's available in the cloud. This is us compared against every single other database vendor in the cloud. If you come to our booth, you'll be able to deep dive with us on performance, but generally we guarantee that if you're moving from a service like Amazon Aurora, Heroku, Google Cloud SQL, that we will significantly reduce your database latency. This demo, I basically show how you can go from 0 to scale very, very quickly, and using sharding. A quick sell for sharding is that it's an incredibly powerful way to horizontally scale your database. We run single clusters with tens of thousands of servers inside those clusters, each individually presenting themselves as like a single connection. So like one connection lying to the app, essentially presenting as one database and allowing you to connect to many, many more nodes, kind of gaining this almost infinite horizontal scalability. Sharding's always had a bad name. I'm sure a lot of us have spent our time and careers avoiding sharding. This is from a very well-known QCon talk from Theo Schlossnagel. It's very difficult. I think we all have that impression in our heads and remember like the early days of when people were trying to shard. I'm here to kind of show you how simple and easy it is to do now. So here's my demo. Another website we all remember is Slashdot. I created Slashrot, which is brainrot and Slashdot mixed together. I have just a script that's just generating load on this site just to show you that this is like real and application queries are going on live. This is the PlanetScale dashboard. I chose to show you sharding instead of all the other fun things like PlanetScale Insights, which tells you when to add queries, add indexes and schema changes. We also like generate anomalies when you mess with your database, and we allow you to deploy schema changes as if they are sort of GitHub pull requests. But anyway, we're going to go through a sharding demo. So I have two clusters here, an unsharded cluster where the primary database that Slashrot is talking to is hosted. And just for like time, I have the pre-baked cookies coming out of the oven, which is an 11 shard database cluster. I meant to put 16, but I accidentally set it to 11. It still works, so that's fine. And I'm just going to quickly talk about how we're achieving this. So this is an app hosted on Cloudflare, connected to PlanetScale. We have a very simple schema, a user table, a post table, and a comments table. The thing we bring to this is a v-schema. So this is a way of telling Vitess how to shard your data. So it's fully transparent to the application. The point of this demo is to show you that we can do this live without changing any single application code and having everything sharded really nicely. The key point here is we're telling Vitess to handle ID generation. So we're taking ID generation into Vitess's hands, allowing us to generate IDs centrally, and so we can shard across many, many machines and gain that kind of scalability. And we're saying we're going to just auto-increment IDs centrally with Vitess in what's called a sequence table. So this is just the very simple v-schema. I'll show you these in the product, and then we'll go through a demo. Sorry, I'm trying to be very quick so that we get to see all this. So I will just show you the cluster configuration. We have the v-schema here. We are telling PlanetScale that we want to shard on the post ID and that we're going to keep the comments table on the same shards as the posts. So we're going to break the posts out, make sure the shards come with them so that the joins and lookups we do stay within a single shard. And again, this is entirely transparent to the application. Okay, so I'm going to go through creating what's called a workflow. This is a workflow that is going to migrate data into the unsharded key space transparently, and then we're going to cut traffic over to that unsharded key space. I will quickly show you this other application I have here called Shard Visualizer. All this is doing right now is counting how many posts and how many comments are going into the database, and then when those tables on those shards are created, we will see them get created and start to fill up, and you'll start to see them distribute very evenly across the shards. So that's so you can kind of visualize a bit of the magic happening as it goes through. So we are going to just call this workflow Ruby. We are going to select comments and posts. We're leaving users in a central unsharded key space, so that will stay the same, but it looks exactly the same to the application. We're moving from the /rot key space into the sharded key space and going to validate this. It's essentially checking that the vSchema works. We're going to create that workflow. And as if by magic, you're going to start to see this go through the checks. It's creating the sequence tables. So those sequence tables are now a central place that we manage those sequences for auto-incrementing. We're now copying the rows over to that sharded key space. It's all just happening live online. And this will take a couple of seconds. You can see that /rot is still operating. We're still creating posts and comments. I've kept this amount of data deliberately slow, but we regularly do this on data sets that are hundreds of terabytes in size, again, as a fully online operation. Let's see while this happens. It's just basically validating and making sure that everything runs. There you go, it's created the tables. You can see that we're automatically connecting. We are filling and distributing up. So now we've gone from a 3-node database cluster to now 11 shards, each with 3 nodes within it. You can see that it's distributing those evenly across the cluster. And the data copy is happening. Let's just wait for that to go. Bearing in mind, this is what used to be like potentially years of work for very large sites to go and actually do this. A lot of people tackle application sharding, which is like very painful and difficult to do. This is all just completely transparent to the app. Still copying the data. It shouldn't take much longer. Right, it's done it. So it's copied the data over. Traffic is still going through to the old sharded cluster, and now we're going to switch our traffic over, fully online. We'll start reading from the sharded cluster, and we will no longer need. I could hit the verify button that would actually just check that it's fully consistent. There's no point wasting time doing that. So I'll go to press to switch traffic. You'll see that /rot still works. We are now serving from the sharded cluster, and we have gone from 0 to sharded in less than 10 minutes. You can see we're serving load from these clusters now. You can see that our edge layer is handling these clusters and sending them off to the sharded database, and that's it, done, sharding, 0 to sharded in 10 seconds. Now we can handle millions of QPS, limitless horizontal scalability, and no shooting ourselves. That's it. That's sharding with PlanetScale. Thank you.